Okay, welcome to your crash course into Excel. So this is a 101 video, just like the Word 101 video was. Really quick overview to a whole bunch of the things that I use commonly in this particular program to show you some stuff that I think will be useful. There'll be a PowerPoint 101 video coming this week as well. And in neither case do I profess to know absolutely everything that goes on within this program. It does a huge amount of stuff that I've never ever even tried to do. I'm just going to show you the things that I think are really useful for an engineer to know how to do. So, jumping into here, once you open Excel for the first time, you'll see effectively this. I'm zoomed right in so that anybody watching it on their phone or whatever can hopefully still see. You get a whole bunch of these cells that you can type data into, or whatever the hell you want to type into them. So if I just come up to a cell and I hit 1, enter, it puts the thing in the cell. Wonderful. Enter. All right. Being slightly more useful. If you put an equal sign in, you can evaluate an equation. 1 plus 2. Calculates it to be 3 for you. Fantastic. Slightly more useful again, equals this cell, so whatever data is in this cell, plus whatever data is in that cell, plus whatever data is in that cell. Enter. 6. Cool. Where it's good is if I change this, everything updates automatically. And then we can go and we can build more and more complex equations. So u equal that number plus that number to the power of this number. Well, where did I mess up there? Plus that number to the power of this number plus, let's put something better in. Sum. So Excel has a whole bunch of inbuilt functions in it as well. You noticed before that I went number plus that number, which effectively just summed all of them. Well, there's actually an inbuilt function for that, sum. So you just select a range of numbers and it will sum all of them together. And you can then embed that within an equation, embedded within an equation. Because there's all sorts of dependencies, right? So this is using cell A4, but cell A4 is using these other cells to calculate itself. Doesn't matter. And you can change any one of these things and everything will just automatically update for you. So that's really cool. And it's basically extensions of this then that allow you to do some unbelievably complicated stuff that you can create. So I'm going to just pick something that we might want to do in Excel and go through and sort of follow it through and show you all the buttons and things that go along with it as just a running example. So my running example here, let's say I want to investigate the function sine x squared. Okay, so you've got this for some reason, you want to investigate it, whatever you're doing in maths or physics or chemistry or blah, blah, blah. So what we could do, and we will do, 0.01. So we're just going to pick a whole bunch of x values and we're going to calculate what our function equals at each one of these values. So we can just go equals, sine's another one of the inbuilt things, sine of x, close brackets, squared. And it calculates what this function would equal at that particular x value. It's written in a kind of weird way. Excel does this. It's got a way of formatting things that when numbers get very big or very small, it uses a scientific notation. So this is effectively saying 9.999967 times 10 to the power of, that's what the E means, minus 5. So it's 0.000009. One too many zeros, whatever. You can change that up here, and I'll show you how to do that later. Anyway, it's a really small number, is the point of the story. What we could then do, 0.02, u equal sine, and we could continue to do this at all sorts of different values, right? But there is a smarter way. So let's start on this side and say what I really want is a whole bunch of x values, 0.001, 0.01, 0.02, 0.03, counting all the way up to something. What I'm going to do is go u equal that number plus 0.01. And it calculates it, right? Great. What I can now do is if I come to this cell, and see you may be able to see in the very bottom right hand corner, there's a tiny little green box. And if I hover over that green box, I get a different type of cross cursor. If I click now and I drag down, it calculates that equation for me in every single cell that I dragged through. And as a result, I can make something slowly count up by a particular number. Another cool thing that you can do in Excel is you actually can do that in an even slightly faster way. If you just do this, write two numbers in, and then grab them both and drag this down, automatically figures out what you want to do and does it for you. Super not actually that relevant. But anyway, I'm just going to grab this and drag it down for a few thousand lines so we get some data to work with. Yeah, come on. So I've just dragged to the bottom of my screen and it's just going to keep scrolling the page down. We'll just go to like 2000. And then I'll go back up. I'll show you a cool trick to get back up quickly as well. Because you'll generally work in thousands of lines of data. So here we are. I could scroll back up with my mouse. I'll get there eventually. I can grab this thing on the side and I can move as well, which is also super useful. If you hold Control and you just hit up, it'll teleport you right up to the top of your column, which is really nice. Well, to the top of where you have data. It'll teleport you to the point where it sees a blank cell. All right. So what we're going to do here is now we want to evaluate the equation everywhere. Now I could do the same thing where I drag this thing down, but Excel's got a really cool inbuilt function as well. I do the same thing. I go to here, hover over where I would get it to drag it down. But instead of dragging, I just double click. It will auto-populate this column as long as there's data directly on the left-hand side of it. So if we do go all the way down, it auto-populated to the point where there was no data on the left-hand side of it anymore, and then it just stopped. Super useful. All right. So now we've got all this data. What am I going to do with it? 2,000 lines worth of data. What am I going to do? Well, I'm going to plot it, right? It's a function that I want to investigate. I want to plot. So this is the other thing that, other than being a glorified calculator, Excel is fantastic for is plots. So you can come up into Insert, and you can come over here to, well, Charts, and 99% of the time, what you're going to want is a scatter chart. So you're going to want to put in some form of graph. Now, I'll do this the slow way, and then I'll show you the fast way to do it. So I'm going to come up here, and I'm going to put in a scatter plot. Right-click, select data. Add, series name, sign, X. Oh, no. Okay. I do this all the time. Basically what it's tried to do here, and this is actually what I should have done. I don't have to type into here. I can just say that cell. And it's going to just take whatever is written in that cell, and it's going to use that as the title. There you go. That was a much easier, smarter way to do it than the way I was trying to do it. Then I got to get my X values, so I got to get all of these X values. If I click on here and I drag for a little while, basically what it's telling me is, if you want to learn how to read this, sheet 1, so the current Excel sheet that I'm on, column A, row 8 through to column A, row 17. So that's the data that it's selected there, effectively. Again, we can use our teleportation sheet. If I click that and I go Control Shift down, it gets everything. So that's super useful. And come up to here for the Y values, click that, Control Shift down. Okay. And then just hit OK. My chart's up the top here somewhere. Seems like it probably didn't go far enough. Why? Why are you only computing to there? I'm confused. Please don't go to 17. Please go to 2,000. There we go. All right. I must have messed up when I selected that data on the left-hand side. But that's our data. This is our equation. So we can see it here as a plot. Um, there's a few more things that we could now do with this, but you get to visualize really quickly, really easy. This takes 2 minutes to make. If we do look at this and we go, oh, cool, that kind of looks like just a standard sine wave. That's not exactly what I thought. Maybe I want to compare it to a normal sine wave. So let's do that. Equals sine x. Double click. This is why I wanted to show you the slow way to do it, because I can now come in and go select data, add, and add a second column. So this is just going to be sine x. The x values are going to be that range, and the y values are going to be that range. Okay. So that's our normal wave, and normal sine wave, and that's our sine squared wave. So now we get to compare the two things. I'm just going to zoom out a little bit. So this is the type of stuff that you can do in Excel really quickly, really easily. Okay. I'll show you a much faster way of plotting this data now, just because I find this super useful. Control Shift sideways, Control Shift down. So I've just selected all my data. There you go. Job's done. Way easier, right? So I'm just going to move it up the top because I don't like how it puts it in down the bottom. There's our plots. Now, there's a whole bunch of different things that you can do now that you have a plot up. We can come in, we can rename our series and things like that. You can put titles in, you can put axis labels in. I find the easiest way to put most of that information is to come up to Chart Tools and add chart element, and you can put in axis titles and all sorts of things like that through here. There are other ways to do it, but I personally just find this the easiest way to do that type of stuff. Another thing that's really useful is you'll often have a lot of data that you got from a experiment or something, but you really only want to look at part of it at a time. So something that's really useful, if you are just clicked away from your sheet and you double click on the axis, you can come in here and you can move these axes, they call them bounds. So you can set a minimum of, say, 5 and a maximum of, say, 10. And it zooms us into this one particular part of our data. So we can actually have a really good look at part of it. I use this all the time, super useful. One of my all-time favorite tricks in Excel is the ability to do that. Another thing that you can do that's super useful is if you want to plot. So these two functions exist through roughly the same range, and there's no real need to plot one of these on a secondary axis, but if, for example, you had some data and you wanted to plot something on a secondary axis, double click on your secondary series, secondary axis, done. There you go. Super easy. Getting two axes in, really, really easy. Side note for you, lines versus points. So insert chart. Should have these been lines or should have they been points is actually dependent on whether this was an equation that could be solved at any value of x or whether it was data that was obtained at discrete values of x. So effectively, if you've ever done an experiment and collected data, you should only ever use points to represent that. If you've calculated something from an equation, you should always use a line to represent that. And you don't basically ever use the smooth lines unless you have a very, very, very specific reason to, because you don't know anything else about the function in between the points that you've evaluated it. So these are generally the only two you'll ever use. And yeah, if it's discrete data, you should always use scatter points. This is probably a much better example for why we might want to zoom in. We just look between, okay, there we go, 8.5 and 9. Now we can actually see that these are discrete points. Cool. All right. You can change the way that it formats some of these things. So if I double click on this data again and I come up to here, fill in line. So no line style, but you can change your line style or your marker options. Probably the most common thing to change is to change these from the automatic size to a smaller size because they're just real big. But you can reformat to make things look the way that you want to make them look. All right, cool. Fits. So something else that you can do to your data, if you left click and then right click, you can add a trend line. So Excel will try and fit a curve for you, a linear, exponential, whatever. It doesn't fit sinusoid, so we actually can't fit this data particularly well. But you can fit a curve to whatever data you have, and you can display that equation on the graph. And oh yeah, this is the equation of my line. If you've got a whole bunch of data that you recorded for some reason. Something that you will see people do quite commonly is come up to polynomial and just keep jamming in the highest order polynomial they can to try and get something that looks nice. Whenever you're fitting a line to a data, you need to have some underlying idea of the science that's going on underneath it. Otherwise, trying to fit it is pretty much meaningless. You will always be able to get a high enough order polynomial that makes anything look good, but is it meaningful? Certainly not, okay? So yeah, unless you got a really good reason to be fitting anything higher than a second or third order polynomial, you're probably not actually helping yourself. You're making it look good, but it's not useful data in any way, shape, or form. But trend lines are super useful things to be able to know how to fit. All right, cool. That's most of what I have for graphs, chart tools. Oh, one thing that I didn't show you that I should have probably pointed out when we were doing equations before is something that comes up a lot of the time where you might want to have an equation where you go, let's say we wanted to put an offset into this data. So we wanted to shift all of our data down by a half. So this equation, let's say, we wanted this to be that minus 0.5. The issue is if we put it into here, and we can do that, it's a little bit messy to change. What you might do, probably a better way to do it, is to have a cell somewhere that it was offset 0.5. Right, so it's just a slightly better way of representing it, because you can change this and it'll update everything better. If, however, I come in and I double click here, what happened was it tried every time it moved the equation down, it moves where it's looking for this offset as well. Now I can solve that by making sure that there is an offset number that goes with every single row, but you don't need to. I'll show you what you do. What you can do is if you put a $sign in, don't know why it's a $sign, but it is, a $sign in before either the row or the column, it will basically hold that stationary and use that same one regardless of which row you're in. So it still updates this A column, but it no longer updates the offset. So that's really cool. If you're actually typing it in for the first time, if you hit that and then you hit F4, it'll automatically put $signs in as well, which is cool. Okay. That's a trick. You don't need to know that, but that can save a whole heap of time. Cool. Done that, done that, done that. Useful inbuilt formulas. All right, sweet. So I'm going to show, we've had a look at some of these already. We've had a look at the fact that Excel can go sum, which is super nice. It's got hundreds of these things. As you can see, they're all the ones just for S, but I'll just talk about some of the ones that I use commonly. So we've seen sine already. Degrees is another one. So this is actually all in radians. So Excel by default is set up to work in radians. So if you want to work in degrees, you need to be able to convert between degrees and radians, and it can do that for you. You just got to remember to type it in. It will do if statements. If statements are great. If this number is, I don't know, greater than that number, be a 7, and if it's not, be a 12. Whatever, because you can do if statements. And you can nest them. You can have ifs within ifs in different cells referencing things. You can make horribly complicated equations in here. And I've seen some I've made some horribly complicated stacked if statements in Excel. It's not the prettiest programming language, but it can be done. There's average, there's sum, stuff like that. But most of those ones that you'll think of, it does really easily. I'll show you random and concatenate though. So rand is one that I use quite a lot. So it generates a random number between 0 and 1, or you can do rand between. This is pretty cool. Bunch of random numbers. Oh, I have too many cells selected. Yep, so generate a whole bunch of random numbers whenever you need randomness for dice rolls or whatever it is that you're doing. And then the other one that's super useful is concatenate. So, by far the most commonly used example. You have a student number and you want to make an email address. So, equals concat. Concat's a list or range of text strings. So it's a whole bunch of little strings of text that you want to put all together into one cell. So text 1 is C, comma. Text 2 is a student number. That's a random number. That's not an actual student number. And text 3 is going to be at uon.edu.au, right? And you just have to put that in quotation marks, at uon.edu.au, and your quotation marks and your brackets. Bam. One cell with all of that information in it. And then I can copy that, take it to... I'll just reformat that slightly for you. There you go. It is one cell with all of that information in it. Copy that, go to Outlook, paste it in, email. All of the people who I had as a previously just a bunch of student numbers, I can make email addresses out of. So that's something that doesn't come up often, but when it does, it can be a lifesaver. Okay, so one thing to mention, and it didn't really seem to happen in this video, it happened a lot when I was practicing, was Excel was really slowing down once I'd plotted these things out and I had them on the screen. And it's because the way in which Excel represents data is it's actually plotting thousands and thousands of points all as their own individual little bit. And that's really taxing way of doing it. So it's really nice in some formatting scenarios, but it's generally really hard on the hardware of your computer. So Excel is really slow with really big data sets, particularly once you've done things like custom formatting into charts. So be aware of that. Can be very useful, can be really, really, really slow. If you've got huge data sets, I'm talking greater than 1 million points, it may no longer be the best option for you to continue using Excel. But you'll learn. Cool. There is one other thing that I was going to show you here, and it's how to do what I call iterative solves. So if you have an equation like x is equal to, well, x is equal to 1 on sine x. This is the type of equation that the only way to solve it is to take a guess at x, check what your formula is, take another guess, check what it is. Now, I was going to show you how to do that, but I went looking on the internet for, hey, what's a good example that first-year engineers would have seen of a equation that required an iterative solve, like this one. And I found it as an example. And then attached to it was a really good video on how to solve it in Excel. So instead of repeating all of the things that are in what's already been created as a really good video, I'm going to put that person's video link in the description. Go and watch them because I think they deserve the views as much as anybody. So, in the description is a link on how to do iterative solves in Excel, which you can do, which are really cool. All right then. So from here, What I'm going to do is go back to what I did in the Word 101 video and just run through the banners and show you what each of the buttons that I commonly use does and how it can be helpful to you. So, starting with our standard home tab, copy and paste, I assume are things you already know how to do, but there is something in Excel that you can do. Well, you can do it in other platforms as well, but it is useful in Excel. So this is a bunch of random numbers, right? And they are going to actually change every time I hit enter because they get recalculated. Let's say I didn't want that to happen anymore. I've got my random numbers and I just want them to be numbers now. I don't want them to be things that are attached to equations. If I copy them and I paste them normally, just Control C, Control V, they stay as random numbers. Or if I come over here to a cell and it's got a dependency and I copy it and I paste it, it's still looking for these dependencies, right? So anything that I just want to bring across as straight up numbers, copy it normally, but when you paste it, go to right click and paste values. Now these things are now just numbers and nothing else. There's no dependency. As these numbers over here now change, it doesn't affect them anymore. Okay, so slight addition to the copy paste, and you can do that, these types of pastes, to do things like bring formatting and stuff like that, or not bring formatting and stuff like that. So that's pretty useful. This is pretty stock standard stuff. It's fonts. I assume you know how fonts work. The only thing that would be different to Word in this case that you might use a lot more is the border button here. So all sorts of different borders here. Because so often what you're doing in Excel is tables of data, having headings and columns and things can be real useful, and a nice way of highlighting them is often to put borders in to sort of separate out data and stuff like that. So you might use that button a bit more as well. These are just formatting. Do you want to be centered in the X and the Y direction effectively? Merge and centers, fairly popular for putting in titles of, if I wanted this to say, it gets kind of left aligned, you can grab these three cells and go merge and center, and then it puts it in the middle for you, right? All right, so that's all well and good. Now, there's a few things that come up with column width and actually fitting all of your information into one particular cell. So if I come in here into this particular cell and go what happens is if you put a lot of data in a cell, it just kind of lets it bleed over into all the cells next to it as long as those cells are blank. But as soon as a piece of information goes in the cells near it, it totally cuts it off. And now you can't see what was written in here. If you click on it, it'll show up the top. But what if you actually wanted that to display within the cell? What you can do is you can grab this cell D and you can make it wider. But how wide? How wide does it need to be? How wide? Okay, that wide. If you come up to here where you were dragging it around and you just double click, it will auto size the cell to be the width of the widest piece of data that you have in there. So that can be super useful. If you have a whole bunch of numbers, so what happens if I make my cell too small is it's actually rounding them down. And we're sort of losing information here in the rounding, so you can just double click and it will make your particular cells the correct size. Super useful. Now, what if, however, we didn't have that in cell D? What if that was in that cell? And we did this. And it made reading our data really annoying because it spread it out way too much. And it's really only this one particular cell that's spreading everything else out. I could actually change its width that way, but it doesn't text wrap by default. So you need to hit this button here to make it text wrap, and then we can make our cell smaller and it will work. Okay, you've got to remember to text wrap though. So yeah, you can reformat things to look a lot nicer that way. Cool, that's all of that. All right, this is, remember how I said I'd talk to you about the way in which it formatted? That's what these cells do. So when you get these numbers in here, in I would say in general, leave them alone, don't touch them. But you can pick different ways of representing data. So scientific representations or percentages or numbers. So if you pick numbers for your data set, basically what it's done here is it's picked a number and it's rounded it to 2 decimal places. Now these 2 buttons here allow you to add more or less decimal places to the data. Okay, so that's a thing that you can do if you don't like the way it's formatting and if it's putting exponentials and stuff like that in there and you don't want it to do that, you can change it to number and you can then set a number of decimal points and stuff like that. The main time where Excel formatting gets you is if you want to do just write a half for some reason into a cell, you freaking can't. Thinks it's a date and it changes it and it's painful and you might have to come up and change it to something else to get it to work. Okay, so it does it all the time, changes stuff to date, super annoying. If that's happening to you, this is where you fix it. All right, cool. Away from that. Conditional formatting. Conditional formatting is great. I think that this is one of the most useful things that Excel does for you when you first get a set of data. So let's say you've got this data over here now, and these were our random numbers that we generated before, right? So this is just 2 columns of random numbers. If I wanted to say, go to color scales and go to there, I'm actually just going to grab 1 column at a time because it'll be a little bit cleaner. Color scales, go to there. This highlights in green the highest numbers and red the lowest numbers. So if you just got a huge heap of data and you want to very quickly look for outliers or something like that, this is a fantastic way to do it. Another one that you can do instead of color scales, and there's all sorts of different options in there. Top and bottom rules, so give me the top 10 or the bottom 10 or above average or whatever, really cool. Greater than 0.5. This shows me all of the ones that are bigger than a half, or maybe I would have been, say, looking for things that failed my test, and I have a particular threshold for a pass or a fail, and I can look at everything that's below the threshold or above the threshold or whatever. So really, really useful ways of very quickly processing your data is with these highlighting cell rules, conditional formatting, sorry. Clear. All right, so that's automatic stuff. There's also these styles in here that you can change. So if this was a bunch of data and I knew that I had to, I don't know, go back and check that it was valid or whatever. Good, bad, neutral, haven't checked them yet, still need to get around to it. Whatever. Really useful. There's a lot to this. There's heaps and heaps of different ones that you can use here. I never really use more than about that many, but if you wanted to format something really nicely, maybe if you're working in a team, maybe you would make much better use of this. You can insert rows and columns. I never use these buttons to insert rows and columns. When I want to insert a row, I just right click and insert a row. Or if I want to insert a column, I just right click and insert a column. I don't know why I don't use the ones up the top. I just find it, just in my brain, it makes much more sense to use the right click to insert. You got a few other commonly used buttons. We're actually going to look at sorting in a minute, so I'm not going to look at it now. These are some of the commonly used functions. I find, with the exception, I don't use this button ever. I just type them in. I find it's way faster, but there's a lot there. Maybe if you're not sure exactly what functions are in Excel, you can look at a bunch of these, and it might help. Another little trick, and I think you have to enable this, but it seems to be enabled by default for me. If you look down the bottom right here, average, count, sum. So a bunch of those equations are actually always being calculated for you on any data you select. So at any stage, if you go and select a bunch of data and you just want to know what it sums to, don't bother writing an equation, just look down there. If you do want to have a cell with what it sums to, Alt equals puts a number in down the bottom which calculates it for you, just in case you're interested. And I never used the find option. All right, so that's basically it on your homepage. If we move over to our insert tab, and you've already seen this, insert scatter plot. Other than that, this entire tab is useless. Very occasionally you might insert a bar graph, and maybe that's useful to you. I've literally never. Okay, there are some scenarios where pivot table could be useful. I've never inserted one of these in my life. I've never used Bing Maps within Excel. Never used any of this. I never bother. Most of this, I think, if you're going to do this type of stuff, you're probably going to move it into a report format anyway, and I would do all of this. I wouldn't do any of this formatting within Excel. Same deal with page layout. I don't use this. Again, if you want this data in a way that you're going to present it to somebody else, generally you're going to put it in a report, so I don't use this. Formulas are sort of in the same boat. Yes, we've talked about they've got some formulas in here which are useful, but most of the time, if I want them, I just equal sum, type them in. So again, I don't find any of this particularly useful. I know a lot of this is useful in default scenarios like financials, where there's common equations that you just use all of the time. Great, they might be super useful to those people, but I just find I type my own equations in just as quickly as I can find them here. Trace dependencies can be useful when things get really complicated. So it will show you which equations rely on this particular cell. And it says this cell, that equation there, and that equation there rely on it. Can be useful. Generally not. Probably most useful if you get somebody else's Excel sheet and you're trying to figure out what the hell it does. That can be useful. Data. Most of this I don't use, with the exception of two things that I use all the time. So the two things that I use all the time is the sort function and text to columns. So I'm going to do the sort function first. Let's take our random numbers over here. And let's say I wanted to sort, let's say this was, I don't know, time, and this was values. For a thing that I did, and for some reason I wrote all my times down in the most idiotic order imaginable. And I want to organize them in order of time. So go to data, go to text to columns, and go to sort. And what you can do is pick a column that you're going to sort on, which in my case is going to be, now, hold on. If I selected all of it, it will tell me the titles of the columns. Sort on time, smallest to largest. And you'll notice it'll organize this column, but it'll also organize this column at the same time. So there you go. They're now sorted smallest to largest, and these were the corresponding numbers that went with them. This is super useful. When you've got something in alphabetical order and you want to put it in chronological or whatever, I use this all the time. It's dead useful. And you can do more complicated things with multiple columns and all sorts of junk. Okay, so that's sorting. Filtering works in a similar way. Sometimes you'll use that when you've got more complex data with names and things like that. And you'll go, I do want to see these columns. I don't want to see those columns, stuff like that. The other one that's useful is text to columns. So I'm just going to open up a new blank sheet here. So exiting that thought process, starting a new one, let's assume we've got a blank sheet. And let's assume that we were working on some sort of device like an X-ray diffractometer for a little while, and we collected some data from anything. You've got data from anything, and you've got it as a text file, in this case a DAT file, or a CSV file it's called, a comma separated variable file. These are really common outputs for all sorts of different machines that don't necessarily interface and update with Windows or Microsoft all the time. They'll just output text files or CSVs or something like that. You can read all of that in Excel. And that's actually what some of these things up here are for directly importing this type of data. But something else you can do, Control A, Control C, so I just selected everything. Now I'm going to come up into my Excel sheet. I'm just going to paste it in. I'm just Control V it in. Now if I double click here, so all of this data has actually gone into column A. It separated out the rows really nicely for me, but all of my data is just in this one column, which is not really what I wanted, right? I wanted each number to kind of be in its own column. That's what text to columns is for. So I'm just going to select all of column A by just clicking on A. So you can just select the entirety of a column or a row that way. Go text to columns. Now you're going to get two options here. Delimitated or fixed width. So if you've got a characters such as commas or tabs separate each field. So a comma separated variable file, by default you'll probably use this. So that's if there was commas between all of my numbers. There's not in my case, there's a series of spaces between them. So I want fixed width. But either or, one or the other will be appropriate to separate out your variables. If you trust it, you can just hit finish now. But I'll just show you what it's going to do. It's going to try and make a new column at each one of these spots. Yep, I agree with that. Some things around formatting. Yeah, whatever. Don't touch them. And now you've got all of your data correctly laid out. So each is a number inside of its own individual cell, and you can now process this and work on it. Do whatever you want to do with it, right? There's a whole bunch of other stuff in here to clean up data. I don't tend to use any of it, but it's there. Maybe you will. I don't use any of that ever, and I don't use any of that ever. Oh, yes I do, sorry. The one thing in here that is useful is freeze panes. So I'm going to go back to my other sheet. I'm just going to just to make this a little simpler, I'm just going to delete all of those. All right. So you can see that I've got all this data here. Oh yeah, I deleted your reference. That's fair. So this thing is freaked out because it was requiring a cell that doesn't exist anymore. So it's freaking out. So I'm just going to change my equation real quick. All right. So I've got all this data here, and I've got these labeled headings for my columns. But if I scroll down, I lose which one those headings are, right? There's actually a way to prevent that. So what you can do is come up to here, and you can freeze panes, freeze top row. Obviously, you can do the same for the columns as well. Freeze top row. And now they stay with you all the time. So that's cell 1 always, regardless of where I actually am in my spreadsheet. So it keeps all your headings there for you. And when you've got 50 columns of data, this is super useful. So freezing panes is really nice. Okay, other than that, I don't use any of the other ones. Again, you might be able to find all these cool things that save you hundreds of hours, but these are the ones that I've learned so far and the things that I think are useful for you to know. So I hope you found the video useful. Overall, I would say the number one thing with Excel in order to be good at it is Google it. There is a gazillion tutorials out there on this type of stuff. If you want to know how to do an iterative solve in Excel, Google it. If there's something that you're finding is really difficult to do in Excel, Google it. I'm sure there's a button for it hidden somewhere and somebody knows how to find it. All right, cool. Thanks, and look forward to the PowerPoint one.